Circular motion and rotational dynamics, the spinning secrets of nature. Motion in a circle, more than just going around. When something moves in a circle, it might look simple, but it's actually a very special type of motion. Unlike straight line motion, here, the direction keeps changing every second. Even if the speed stays the same, the object is still accelerating because acceleration is about change in direction as well. Think of a child on a merry-go-round. The speed may be constant, but the feeling of being pulled sideways is real. That's circular motion in action. The role of centripetal force for circular motion to happen. There must always be an inward pulling force. This is called centripetal force to force that keeps things moving in a circle instead of flying straight. Examples. The string pulling a stone as you whirl it around. Gravity keeping the moon in orbit around Earth. Friction between car tires on the road as the car turns around a bend. Without centripetal force, everything would just go in a straight line and no circles would exist. Everyday experience of circular motion. The thrill of a roller coaster as it loops upside down your body is held by centripetal force. The swirling of tea leaves in a cup, gathering at the center as you stir. An airplane banking in a curve, with lift providing the centripetal pull. Circular motion is everywhere from play rides to planetary orbits. Rotational motion, when objects spin. Circular motion isn't just for moving around a path. Whole objects can spin around their own axis. That's rotational motion. Examples. The spinning of Earth giving us day and night. A ceiling fan rotating around its center. A spinning top balancing itself as it twirls. Rotational motion introduces new ideas like angular speed and torque. But the essence is, when something rotates, every part of it is in circular motion around the center. Torque, the twist that causes rotation and linear motion. Force makes things move. In rotation, the equivalent of force is torque, twisting push. Examples. Opening a door by pushing its handle further from the hinge. The more torque you create, using a wrench to tighten a bolt, the longer the wrench. The easier it is, because torque increases. Torque is the rotational force that starts, stops, or changes spinning motion. Moment of inertia. Mass matters in rotation too. Just like heavier objects are harder to push in straight motion, objects with more rotational mass moment of inertia are harder to spin. A lightweight bicycle wheel spins. A heavy potter's wheel resists sudden changes in its spinning. A figure skater pulls arms inward to spin faster, reducing moment of inertia, increases rotation speed. Moment of inertia is like the inertia of rotation. It decides how stubborn an object is against changing its spin. Conservation of angular momentum. Nature loves balance. And in rotation too, momentum is conserved. Angular momentum stays constant unless an outside torque interferes. Examples. A spinning ice skater pulls arms close and spins faster, speed changes. But angular momentum stays the same. A spinning wheel in space keeps spinning forever without slowing down because there's no external torque. Planets keep orbiting the sun because their angular momentum is conserved. Circular motion and rotation in the universe. Circular and rotational. Motion aren't just small tricks there, the language of the cosmos. The Earth spinning on its axis. The moon orbiting Earth. The galaxies themselves rotating majestically in space. From electrons spinning around nuclei to planets circling stars, rotation is nature's favorite dance. Why circular motion and rotational dynamics matter. These concepts explain why satellites stay in orbit, why machines spin, why athletes adjust their posture to control speed, and why the universe looks the way it does. Circular motion shows us the invisible poles that keep paths curved, and rotational dynamics reveal the hidden rules of spinning objects. Together, they explain both the fun of a spinning top and the grand orbits of stars and planets.